Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about sections of the solid. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a right circular cylinder having base diameter 40 millimeter and axis height has been provided to us as 70 millimeter. Now this right circular cylinder, it is having a circular hole of diameter 30 millimeter drilled centrally through it, and this hollow cylinder happens to be resting onto its base on the horizontal plane. So this is the hollow cylinder in which the outer diameter happens to be 40 millimeter while the inner diameter happens to be 30 millimeter. And this cylinder is standing upright on its base onto the horizontal plane. Now we have been provided with the information that an auxiliary inclined plane inclined at an angle of 45 degree with respect to the horizontal plane, it cuts the cylinder in such a way that it passes through the right top corner of the cylinder. So this is the right top corner of the cylinder. So this cutting plane passes through the right top corner of the cylinder and it is inclined at an angle of 45 degree with respect to horizontal plane and it is perpendicular to the vertical plane. Now we are required to draw the sectional top view, the front view and the true shape of the cut section of the right circular hollow cylinder over here. So let us now first of all evaluate the orthographic projections of this hollow cylinder when the cylinder happens to be resting onto the horizontal plane on its base over here. Now when the observer is going to look at this cylinder from the top, so the observer will be able to visualize the circular projections corresponding to the outer, that is 40 millimeter, and the observer will also be able to see the inner circular portion corresponding to the drilled hole over here. So two circular projections, one having the diameter 40 millimeter and the inner one having the diameter 30 millimeter. So both of these circular projections, they will be visible to the observer. So now we can see we have drawn the circular projection corresponding to the outer radius of 20 millimeter or the diameter is equal to 40 millimeter. Now we have divided this circle into 8 equal parts and the included sector angle will be 45 degree over here for each of these sectors over here. Now having drawn the outer circular projection corresponding to the cylinder, now we also know that the height of the cylinder happens to be 70 millimeter. So this is the axis point O and O1. Now through the axis point, now if we are going to draw the axis over here and we mark the axis height as 70 millimeter, so we will be able to obtain the front view projections corresponding to the cylindrical portion over here, and we will be obtaining 8 points: 1 dash, 2 dash 8 dash, 3 dash 7 dash, 4 dash 6 dash and 5 dash corresponding to the top face of this particular cylinder, and the top axis point, that is O dash, has also been marked over here. Now we know that the inner cylinder, that is corresponding to the circular hole, this is having the radius 15 millimeter or the diameter 30 millimeter. So this inner circle we have marked with orange color over here. So now the inner circle has also been projected onto the horizontal plane. Now again this inner circle corresponding to the hollow cylinder has been again divided into 8 equal parts, and the 8 points, they have been marked as A, B, C, D, E, F, G and H over here. So the 8 sectors corresponding to the interior circle, that is the hollow part of the circle, again we have marked over here, and again the sector angle will be 45 degree over here. Now corresponding to this inner hole, now we have to draw the front view projections over here. So through all of these 8 points, if we mark the corresponding projections into the front view projectors over there. Now A dash, B dash, C dash, D dash, E dash, F dash, G dash and H dash. So these 8 points we have marked onto the base of the cylinder corresponding to the hollow portion of the cylinder, which is going to have diameter equal to 30 millimeter. So here one thing we need to observe, 8 points we have marked on the top face corresponding to the outer portion of the cylinder. 8 points we have marked on the bottom or the base of the cylinder corresponding to the hollow segment or the inner circle corresponding to the hole which has been drilled into this cylinder over here, which is having diameter equal to 30 millimeter. So in all, 8 points corresponding to the outer circle, 8 points corresponding to the inner circle, they have been marked in the front view projections over here. One thing we must note over here, we haven't marked these 8 points corresponding to the outer cylinder on the base of the cylinder because of the symmetry. Similarly, the 8 points corresponding to the hollow section, we haven't marked at the top face over here, again because of the symmetry, because otherwise we would have got 16 points on the top which would be very close to each other, and again 16 points on the bottom face we would have obtained over here. So now on the bottom face we have marked the 8 points corresponding to the hollow section, whereas on the top face we have marked 8 points corresponding to the outer portion of the cylinder over here. Now we know that a cutting plane, that is an auxiliary inclined plane which is inclined at an angle of 45 degree with respect to horizontal plane and passing through the rightmost top corner of this circular cylinder. It passes through this corner. Now the cutting plane passes through the right corner of the cylinder, and this auxiliary inclined plane happens to be inclined at an angle of 45 degree with respect to the horizontal plane. So this portion of the cylinder has been cut out by this auxiliary inclined plane. Now we observe that there are 8 points of intersection corresponding to this outer circular portion of the cone with respect to this particular auxiliary inclined plane or the cutting plane. So these 8 points, they have been marked onto the front view projection over here. And which are these 8 points? So we can check point 11 dash. It is the point of intersection of the cutting plane with the vertical generator of the outer circular portion emerging from the point 1 dash over here. Similarly, there are 2 points of intersection, 21 dash and 81 dash. So these 2 points of intersection, they are available onto the outer circular portion corresponding to the vertical generators emerging from the points 2 dash and 8 dash over here. Next we have got 2 more points of intersections, that is 31 dash and 71 dash, which are corresponding to the outer circular portion of the cylinder, and they are corresponding to the vertical generators emerging from the points 3 dash and 7 dash over here. Then we have got another 2 points 41 dash and 61 dash, which are available onto the outer circular portion corresponding to the vertical generators which are emerging from 4 dash and 6 dash over here, and corresponding to the outer generator 5 dash. Now we have got a point of intersection 51 dash available over here into the front view projection. Similarly, corresponding to the inner circular hollow portion which has been drawn using this orange color projections over here. Now we find that there are another 8 points available over here. So point A1 dash, it lies corresponding to the inner hole onto the vertical generator which is emerging from the point A dash over here. Similarly, points B1 dash and H1 dash, they are located over here. So these are the points of intersection of the cutting plane with vertical generators emerging from points B dash and H dash of the inner circular hole over here. Similarly, corresponding to this inner circular hole, there are 2 points which are C1 dash and G1 dash. So these 2 points, they are available over here, which are the points of intersection of the cutting plane with vertical generators emerging through the points C dash and G dash corresponding to the inner circular hole. Next, we have got 2 more points of intersection over here, D1 dash and F1 dash. They are appearing over here. These 2 points, they are lying onto the inner circular hole corresponding to the point of intersection of the cutting plane with the vertical generators emerging through the points D dash and F dash over here. Then we have this point E1 dash. So E1 dash happens to be the point of intersection of the cutting plane with the vertical generator emerging from the point E dash over here. So this way, 8 points of intersection, they are available with us in the elevation corresponding to the outer circular portion of the cylinder, and 8 points of intersection, they are available in the front view projections corresponding to the inner circular hole being cut by this cutting plane. Now, having obtained the points of intersection corresponding to the outer cylinder and the inner cylinder in the front view projections, so if we bring these projectors in the top view, now if we bring the vertical projectors to these front view points of intersection of all the 8 points onto the outer cylinder into the top view projections, we observe that all of these 8 points of intersection, they will be coinciding with their originating vertical generators in the top view projections over here. So point 11 is the point of intersection which is available on the vertical generator through point 1 dash. So if we are going to look at this particular point from the top, so we are going to see that point 1 dash and 1 dash, they have coincided with each other. Similarly, the POI 21 dash, it appears on the vertical generator emerging from the point 2 dash over here. So in the top view, 2 dash and 21 dash, they have coincided with each other. So similarly, the points of intersections 31, 41, 51, 61, 71 and 81, they have coincided with the vertical generator points 3, 4, 5, 6, 7 and 8 over here. Similarly, the 8 points of intersections which are available in the front view corresponding to the inner hollow cylinder, these points, they are also going to coincide with their vertical generator points over here in the top view projection. So we can see here we have got point A1 dash as the point of intersection of the cutting plane with the vertical generator emerging from A dash. So in the top view projections, A dash and A1 dash, they will be coinciding with each other. Similarly, the points B and B1, C and C1, D and D1, E and E1, F and F1, G and G1 and H and H1, they have also coincided with each other. So this way, we have been able to obtain 8 points of intersection corresponding to outer cylinder in the front view projections as well as in the top view projections over here. Similarly, the 8 points of intersections of the cutting plane with the inner portion of the cylinder have also been marked in the front view projections as well as in the top view projections over here. Now we are required to evaluate the section top view. So we can see that this cutting plane, it passes through whole of the cylinder. At some points they will be intersected on the top portions, whereas some other points it is going to intersect with the cylinder at the lower portion over there. But when we look at this cut section from the top, so whole of the cylinder, it has been sectioned by the cutting plane which is inclined at an angle of 45 degree with respect to the horizontal plane. So the top view section portion corresponding to this hollow cylinder has been obtained over here, and it has been appropriately sectioned in the top view projections. Now we are required to obtain the true shape of the cut section of the cylinder over here. Now we have to look at this cut portion of the cylinder from this orientation. So we know that this is the remainder portion of the solid which is left behind, right? So we have darkened this portion as well, and now we are going to draw the true shape of this cut section. Now we know that since this cutting plane happens to be inclined to the horizontal plane, so the top view projections which we have obtained corresponding to this cut section of the cylinder over here, it is the apparent shape projections of this cylinder we are able to obtain over here into the sectional top view. So in order to obtain the true shape corresponding to the cut section, we need to draw an auxiliary inclined plane x1 y1 which will be parallel to this auxiliary inclined plane which happen to be inclined at an angle of 45 degree with respect to the horizontal plane. And now since this AIP x1 y1 is parallel to this cut section, so the auxiliary plane projections which we are going to obtain over here will provide us with the true shape of the cut section of the circular hollow cylinder over here. Now let us obtain first of all 8 points into the auxiliary plan view projections corresponding to this outer surface of the cylinder. So we have marked all these points using blue color, right? So point 11 dash is located over here. Now first point which we are going to draw onto this projector line which has been drawn perpendicular to the x1 y1 reference plane over here, it is point 11 over here. So you can check. First of all, we are going to mark the distance between the reference line xy and the point of intersection 11 into the top view projection over here. So once we mark this distance of 0.11 from the xy reference line, now onto the projector line emerging from the 0.11 dash, this distance we are going to mark ahead of the plane from the x1 y1 AIP over here. So in front of x1 y1 auxiliary inclined plane, we are going to mark the distance of 0.11 which will be equal to the distance between xy reference line and 0.11 over here. Next point we are going to mark is this point, 0.21 over here. So 0.21, once again we are going to measure the distance between xy reference line and the 0.21. Now onto the projector line drawn through the 0.21 dash. Now ahead of the plane x1 y1, same distance of 0.21 from the xy reference line will be marked over here. Next point we are going to draw is 0.81. Now again we can check. We are going to measure the distance of 0.81 from the xy reference line, and onto the projector line drawn through the 0.81 dash, same distance ahead of the plane we have marked it out over here. So we have located the 0.81 in the auxiliary plan view projections over here. Next point available with us is 0.31. So again we have measured the distance of 0.31 from the xy reference line. Now onto the projector line emerging from 31 dash, this distance we have marked it out over here onto this projector line. So 0.31 distance from the reference plane x1 y1, so this will be equal to distance of 0.31 from the xy reference line over here. Next point available with us is 7.1. So we'll measure this distance of 0.71 from the xy reference line. Now onto this projector line, if we mark the same distance, we will be able to obtain the 0.71 over here in the auxiliary plan view projections over here. Next point available with us is 4.1. Now once we measure the distance of the 0.41 from the xy reference line, now onto the projector line emerging from 4.1 dash, ahead of the plane same distance has been marked over here. Similarly for the 0.61, we have measured the distance between the 0.61 and the xy reference line, and now onto the projector line emerging from 6.1 dash, same distance we have plotted onto this projector line over here ahead of the plane. And the last point corresponding to the outer circle, it is phi 1. So now corresponding to point phi 1, again we have measured the distance of point phi 1 from the XY reference line and onto the projector line emerging from the point phi 1 dash, we have marked the same distance over here. So this way, all the 8 points corresponding to the outer circular portion, they have been evaluated and appropriately marked into the auxiliary plan view projections over here. Now next we have got 8 points corresponding to the inner circular cylinder over here. So corresponding to these 8 points, we have now drawn the orange projector line. So now onto these orange projector lines, 8 points A1, B1, C1, D1, E1, F1, G1, H1, they have to be evaluated onto the auxiliary plan projection view. Now first point available with us is A1 now. We'll measure the distance of point A1 from the XY reference line. Now onto the projector line emerging from A1 dash, same distance we have marked over here onto this particular projector line, that is the orange projector line. So this is the location of the point A1. So distance of point A1 from X1, Y1 and the distance of point A1 from XY will remain the same. Similarly, we have got point B1 over here. We'll measure the distance of point B1 from the XY reference line. Now this is the projector line emerging through the point B1 dash. So onto this projector line, same distance ahead of the plane, we have marked it out over here. So point B1 has been evaluated into the top view projections over here. Next point is H1. Now corresponding to H1, we have evaluated the distance between XY reference line and H1. And now through the projector line emerging from H1 dash, same distance we have plotted ahead of the reference plane X1, Y1 over here. Then we have the points C1 and G1. So again we have evaluated the distances of C1 and G1 from the XY reference line. Now onto this projector line which is emerging from C1 dash and G1 dash, same distances corresponding to G1 and C1 we have marked it onto this orange projector line over here. So C1 has been marked over here, G1 point has been marked over here. Similarly, next 2 points available with us, they are D1 and F1. Now we have evaluated the distances between XY reference line and the points D1 and F1 over here. So once we evaluate distances D1 and F1 from the XY reference line, now corresponding to the projector line, that is this orange line emerging from these 2 points D1 dash and F1 dash. Now the 2 points D1 and F1, they have been obtained into the auxiliary plan view projections over here. Next we have got point E1 dash. So from point E1 dash, again we have drawn a projector line. Now we are going to measure the distance of the point E1 from the XY reference line. This distance we have measured. So once we measure the distance of the point E1 from the XY reference line, now onto the generator emerging from E1 dash, that is this orange line, we have plotted the same distance over here. So this way, all the 8 points corresponding to the inner circular cylinder portion, all the 8 points corresponding to the inner circular portion, they have been evaluated. So once we have plotted these 16 points of intersection of the cutting plane with the outer cylinder and the inner cylinder, so these points of intersection, once we join them, they will be appearing as elliptical cross sections into the true shape projection over here. So this way we have been able to join inner portion corresponding to this hollow cylinder and the outer portion corresponding to this hollow cylinder. And then this is the section view. So we have applied the section lines over here, and this is the true shape of the cut section as it will be viewed by an observer who is going to view this cut section from this orientation. So here we have been able to obtain the sectioned front view projections, the sectioned top view projections, and the true shape projections of the cut section of a circular hollow cylinder which has been cut by an auxiliary inclined plane at an angle of 45 degree with respect to the horizontal plane, and this cutting plane passes through the right corner of this particular hollow cylinder. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the front view, top view, orthographic projections of the sectioned cylinder and the true shape projections of the cut section when the hollow cylinder has been cut by an auxiliary inclined plane inclined to the horizontal plane. So we are going to continue with further discussion regarding few more illustrative cases of sections of the solids in the coming lectures. So thank you very much. Thanks a lot.